Today, I'm so honored to give a demonstration for you about our study. Our topic is about daily gold prices forecast based on LSTM and CNN model with attention mechanism. So before giving a detailed explanation of our work, you may ask, why this project is worth doing? And basically speaking, a precise forecast in financial data analysis will facilitate the development of economy. However, finance is one of the most computationally intensive fields in the world, since it may be affected by the internal factors like the cash flows or the external factors like the government regulations. Also, even though the economists have applied the mathematical methods like the Bayes algorithm, or later they used quantitative factor models like the CBDCom, they still struggled on making prediction because of the financial crisis in 2008. At the same time, we noticed that deep learning has dedicated greatly on many fields, such as in sentiment analysis and image recognition. The main idea of deep learning is to use a set of data to train the model and making prediction by using another set of testing data. So theoretically speaking, no matter how irregular the data we input, we can still find the relationship for the corresponding return by using deep learning methods. For this reason, with the aim of implementing deep learning on financial data analysis, we designed a method that based on LSTM and CNN model with the attention mechanism to predict the daily gold prices. Let's see our main contributions. First, the LSTM model with attention mechanism is firstly proposed by us on daily gold prices forecast. Second, we do a large amount of experiments in order to prove that our proposed model outperforms than other conventional models. Thirdly, we found that LSTM and CNN model is better than CNN and LSTM model because it causes lower feature loss. Finally, we also found that attention mechanism is a crucial part in our model. It can significantly improve the prediction of daily gold prices. Now, please look at our approach. As we can see on the flow diagram, our methodology can be divided into 4 parts. The first part is data processing, and then is LSTM component, followed by attention mechanism, and finally is the CNN component. First part, data processing. Our data source is released by World Gold Council, and before sending them into the model, we need to use the standard scale method, which denotes as SX, to standardize the data source. In addition, we also set the length of input window as alpha. In this example, we set alpha equal to 7, which means each input matrix contains 7 trading days, and the corresponding output is the first element of each input matrix. After data preprocessing, we then send the data source to the LSTM component. As we can see on the figure, we set the number of LSTM layers as beta, and each LSTM layer consists of input layer, LSTM unit, and output layer. And a common LSTM unit is consisting of a cell and 3 gates: input gate, output gate, and forget gate. Worth to mention that the cell is used to store the information, and the forget gate is to decide whether this information needs to be remained or be forgotten. After the calculation, the output layers will gather all the results as the output of LSTM component and send them to the next progress, attention mechanism. So we get a new encoding from the LSTM component, but a large scale of input data will affect the quality of memories of the LSTM unit. Therefore, it will directly influence the temporal features of the new encoding. To solve this problem, we firstly introduce the attention mechanism into our model. The attention mechanism can better grasp the effective information from the new encoding by assigning different attention weights to enhance the temporal features. This step is really important, and we will prove how crucial it is in the later section. After enhancing the temporal features, the new sequence of encoding will be sent to the CNN component. Firstly, the new encoding will be processed by the convolutional layer. The convolutional layer is good at extraction and reorganization. Therefore, it may help to detect the spatial features of the daily gold prices. We also set the number of filters in CNN as gamma. And then the encoding will be fed to the max pooling layer. The function of it is to shrink the dimension with the aim of reducing the redundant characteristics. At last, the sequence will go to fully connection layer with the linear activation function to produce the prediction results. Now, may I ask you a question? Why should I order our model in this way? We will then give 2 brief illustrations. The first one is the brief structure of LSTM and CNN model, whose order is the same as that of our proposed model. The second one is the brief structure of CNN and LSTM model. The initial layer is CNN component and then followed by LSTM component. In order to prove which way of ordering will have a better performance on daily gold prices forecast, we will provide experimental results and detailed explanations in the next section. Now, let's have a quick see on the experiment setting. We have mentioned that our data source is released by World Gold Council, and it contains 10,471 records during this a period of time. And the performance matrix are listed as following. Worth to mention that the smaller value in the above matrix, the better performance reflects it. Let's look at the results. The table shows that our proposed model has a better performance than other conventional models, especially at the training ratio of 80%. This indicates that the attention mechanism plays an important role in making predictions on daily gold prices. And then please look at these 2 rows. The score of LSTM and CNN is better than that of CNN and LSTM. Why? This seems that although CNN component can extract the local patterns, it may also reorganize the order of input data. Therefore, the time series of the output from CNN component is totally different from that of the original dataset. When this output is sent to LSTM component, LSTM cannot extract the temporal features, but works as another fully connection layer. That's the reason why we use this as the order of our model. For better visualization on what the table reflects, we also sketch the prediction line charts for all the comparison models. Let's have a quick see. As for the parameter study, the first parameter is alpha. As shown from the figure, although we enlarge the size of input with more data, the network may not get better performance on learning features and making prediction. The second parameter is beta. We know that more LSTM layers will be beneficial to feature extraction. But in our situation, our data source is not as large as others. If we add one more LSTM layers, it may cause over-extraction. For the last one, gamma, the more filters in convolutional layer we use, the richer information can be quickly processed by the model and perform better. In conclusion, first, LSTM and CNN model with attention mechanism can effectively make predictions on daily gold prices. Second, the attention mechanism can optimize the forecast we have already proved by the result table. Third, the order of constructing the zero model is a considerable factor, since different structure of model will produce totally different results due to the processing order. Finally, we should construct our own models according to the problem itself, because each model has its suitable area to apply in, and remember to avoid connecting models without aims. So, that's my final year project presentation. Thank you for your listening.